operation, isn't it? In first semester you have done rank calculation of a matrix. That idea you do have little bit, students. In first semester you have done the rank calculation of a matrix.
Yes, sir.
So during the calculation of the rank, what you have done? You have done some elementary row operation, and using that row operation, step by step, you are forming a equivalent row matrix. At the last, by watching the number of non-zero row, you are deciding that matrix how many rank it will have, isn't it?
Yes, sir.
Process of doing that elementary row operations in a manner such that your coefficient matrix will transform into a upper triangular matrix. Suppose a coefficient matrix is suppose A11, A12, A13, A21, A22, A23, and A31, A31, A32, A33. This is the coefficient matrix of a system of linear equations, suppose. And after doing some elementary row operation, anyhow you have to transform. That idea I am telling you here. Suppose first equation is unchanged here. Another equation in the second row is changed by another coefficient, suppose looks like that. And third equation is this type of things. Another. And this position 0, this position 0, this position 0. So after doing some elementary row operation, you are transforming your given matrix, square coefficient matrix, into the upper triangular matrix. Okay. And process of doing this is known as here, actually that is the method, Gauss elimination. With the help of that method, we are solving a system. Okay. So that process and that idea is this method. That is, you just try to nicely understand, okay, what I am trying to tell you. Suppose a system, corresponding system I am trying to write, suppose A11 x1, A12 x2, A13 x3 equals to B1, right hand side, A21 x1, A22 x2, A23 x3 equals to B2, A31 x1, A32 x2, A33 x3 equals to B3. Okay, so suppose in this system, its coefficient matrix is this, isn't it? You just see and watch. Is it clear?
Yes, sir.
Our target is to do your coefficient matrix, means main coefficient matrix of this system is to transfer into the upper triangular form. For that purpose, it will have some rules. That idea or rules, you just nicely keep that mind. Okay. And sometimes, before of that also, I would like to tell you, the process I am discussing here by taking a example 3x3 system, okay, means 3 equation 3 unknown, but this expression or this discussion is valid for n number of equations. This is the general discussion, but example I have taken for 3x3, but this is the general discussion. In that way you should or try to understand. Okay, so what you will do from the given system, in first step, suppose first step, in first step, first equation unchanged. What I am telling you, just try to understand nicely. In first step, first equation unchanged, and with the help of first equation, what you will do in remaining equations such that first position will be 0. This position will be 0. So you have to do some elementary row operations such that in second equation will be updated, this position will be 0. Third equation will be updated, this position will be 0. If you do have more than 3 equations, then also this remaining positions also will be 0, like that. So in first step, first equation unchanged, with the help of first equation, in remaining equation first position 0. You got idea?
Yes, sir. Getting it.
Okay. So to do this 0, you just, how it will become 0 means you have to change new R2 means second row. New R2 is, suppose R2 dash is the new R2, will be updated from old R2, which operation I will do perform in R1. So what I will do in R1, I will, you just see R1, I will do this coefficient 1, R1 by A11, and what is this coefficient? In R2, X1 coefficient is A21, so I will multiply A21, such that if I will perform this operation, this position will be 0, isn't it?
Yes, sir.
Similarly, if I will create R3, means new R3 from old R3, what I will do along with R1, such that this position will be 0. R1 by A11, I am doing this coefficient 1 by dividing A11. And what is this coefficient? That is I am multiplying. Actually, that idea you have to use when you will write the program also. From here we will create or build the formula. Okay. For time being, you just try to remember these things. Okay. So if I will do this operation, this position will be 0, and I will perform this operation in remaining elements, and I will update these elements. Okay. So obviously this position will not be 0. After doing, I will divide A12 by A11, and I will multiply by A21, and I will subtract from A22. So this will build another type of coefficient that is just renamed by A22 dash X2, and this is also new coefficient A23 dash X3 equals to, this is also will be changed by B2 dash, suppose. Okay. In second step, this is and similarly third equation also, actually A32 dash X2, A33 dash X3 equals to B3 dash. In step 2, first equation, second equation, means up to second equation unchanged. So in first step, first equation unchanged, no problem. In step 2, first equation unchanged as well as second equation also unchanged. Okay. So up to second equation unchanged. Okay, A11, A12, X2, A13, X3 equals to B1, and A22 dash X2 plus A23 dash X3 equals to B2 dash. And what I will do operation along with R3 such that this position will become 0 along with R2, means to create R3 dash means new R3, what I will do in old R3 along with R2 such that this position will be 0. So in this case, I will do this coefficient 1. So I am dividing by A22 dash, and what is this coefficient? That is I will multiply A32 dash. If I will perform this operation, this position will be 0. And I will perform this operation in remaining elements also in that row. So this will be new coefficient, that is I rename as X3 double dash, and that is B3 double dash. You just see in two steps. In two steps, step 1 and in step 2, your coefficient matrix was first triangular form. Then it is becoming looks like that type of form. In first step, first position 0. In second step, in third equation and remaining equation, actually second position 0. In that way, it is becoming the upper triangular matrix form. You just see and watch. This is the upper triangular matrix form. So our target is your coefficient matrix to reduce into the upper triangular form. After doing this, you just see and watch from the last equation easily last variable will be come out. That will be B3 double dash by A3 double dash. Is it okay? After getting x3 from the last equation, use that x3 value in second last equation, you will get x2. So use this here, you will get x2 as B2 dash minus A23 dash x3 by A2 dash. So after getting x3, you just put that x3 value here, you will get x2. You will get x2, x3 clear, x2 clear. After getting x3, x2, use that is in first equation, you will get x1. So process of finding this value from back side, step by step, last value, then second last value, then next value, in that way up to first value is coming out step by step from last to first. And this process is known as back substitution. And sometimes this method is known as method of back substitution also. You understood this?
So can you explain the last part once more?
After doing that elementary operations, you are transforming into the upper triangular form. That system, original system, is now transferred into the upper triangular system. In that upper triangular form, you just see in last equation only last variable is there. You don't have the remaining variables. So from last equation, last variable will come out. After getting that value, use in second last equation, you will get second last value x2. So x2, x3 is clear. Use in first equation, you will get x1. So process is you are getting the values from last side, and that is why this is the back substitution. Quickly, you just try to solve it out. If I'm asking you a numerical example, suppose it will be more clear to you. Suppose, and as well as the algorithm also, I will tell you x2 plus 8x3 equals to 26, and 3x1 plus 5x2 plus 2x3 equals to 8, and 8x1 8x2 plus 2x3 equals to -7. Okay, you can replace your equation in any position. So suppose you may put this equation in first position, but one thing you should remember for this technique, in your first equation, first variable coefficient should not be 0. Okay, if any system is given to you, you just see and watch. In first equation, first variable coefficient should not be 0. In second equation, second variable coefficient should not be 0. In third equation, third variable coefficient should not be 0. So if I will put this last equation in second position and second equation in third position, I can able to use this technique and I will get the same answer. But I cannot able to replace this equation in first position. because in the last equation it will not have the non-zero value in the first variable coefficient. So first variable coefficient in last equation is 0, so you cannot able to put this is in first position. So that type of awareness you just try to remember. Okay. So if this equation is in third position, okay, no problem, we can able to solve it. Okay, what I told you in algorithm, in first step, first equation unchanged, 6x1 2x2 8x3 26. With the help of first equation, what I will do in R2 means second equation, such that this position will become 0. Tell me.
So 2 times R1.
No. You are building new R1 from old R1. Sorry, for any row. For any row, you are building any row from old that row. So R2 you are building for old R2. What you are doing the operation in R1?
So
that
minus
is plus
coefficient.
or minus whatever, that is you have to do in old R1.
Old, yes.
Okay.
Old R1 is constant 9.
R1 in first step unchanged, so old or new, what is that does not matter. In first step R1 unchanged. Okay. So old or new, it is, does not matter. Okay. So what you will do in R1, positive or negative subtraction or minus subtraction or addition along with some multiplication, scalar multiplication. That is you have to do in R1.
So
what
which one you have taken it? R2?
R2 is, this is in this position, I have to do this position 0. That will be the new R2. That will be the new R2. And that is the old R2. So what I will do, you just see this is place is 3. So first of all, in algorithm, I told you make this coefficient 1. So you will divide by 6 and multiply by 3. And you will subtract. So what is that actually? Multiply by
Coefficient, sir.
multiply, you first of all divide by 6 or and multiply this coefficient and subtract. That is the formula I told you. Divide by coefficient means that coefficient is here and multiply this coefficient. Okay. So or roughly you just see and watch what you will do. If this is 3 and this is 6, so to do this 0, what you will do in this row? You just divide by 2. Simply
1 by 6.
Divide by 2.
Oh, sorry, it's 2. Yes, sir.
Divide by 2. Simply it will become 3. Then subtract. Simply this position will be 0. So simply in R1 you are dividing by 2 and subtracting. Okay. You got this?
Yes, sir.
Then tell me. And that operation, this is become 0. That operation you just perform in remaining elements also. So what it will happen? 5 minus that operation. 5 minus 2 by 2. R1 by 2. 2 by 2 means 1. 5 minus 1 means 4. 4x2. That operation you have to perform in remaining elements also. x2 plus 2 minus 4. 8 by 2 means 4. 2 minus 4 means 2 minus 4 means minus 2. You are getting, this is 2. 2, you are subtracting this. Minus 8 by 2. 8 by 2 means 4. 2 minus 4 means minus 2. x3 equals to 8 minus 26 by 2 means 8 minus 13.
So which one you have taken?
Which one means?
Okay. R2 5 minus 10. Oh yes, sir. Got
Okay.
it, sir.
8 minus, now right hand side, in right hand side also that operation you have to do. 8 minus 26 by 2 means 8 minus 13. 8 minus 13 means minus 5. And this position in first step, first equation unchanged, in remaining equation first place 0. You just see this position 0 in third equation. So you just don't have to do anything in third equation. So 8x2 plus 2x3 equals to minus 7. That is your first step. You got this. Is it okay? बोलो समझ में आया कि नहीं बोलो.
आया सर.
Second step, up to second equation unchanged. Up to second equation unchanged. 8x1 plus 2x2 plus 8x3 equals to 26. 4x2 minus 2x3 equals to minus 5. And what you will do in R3 along with R2 such that this position will be 0. What you will do in R3?
Sir, multiply by 2.
Minus, you just see this is also positive, this is also positive, so it is 8, it is 4. So
Minus.
I am, by watching this, I am doing this is multiplying 2 into R2. Okay, hold R2 or whatever, up to R2 is unchanged, so no problem. And that operation I will perform for remaining elements also. So this position is become 8 minus 8. This is 0. Okay. What will be this position? 2 minus 2 into 2. And
Plus
that
2,
is minus. Minus minus plus. So this will be
plus 2.
6. 2 minus minus plus 2 into 2 means 4. Plus 4 or 2, 6. 6x3 equals to minus 7 minus minus plus 5 into 2 means 10 plus 10 minus 7 plus 10 means what is that? Minus 7 plus 10 means 3. Now you just see this given system. Actually, you know, these are actually elementary row operations, and you know, you have done during the rank calculation using any elementary row operation, whatever the matrix I am getting, that matrix is the equivalent matrix. So basically this system is, original given system is equivalent to this system, as well as it is equivalent to these systems. Means equivalent means whatever the solution of this system, that is equals to solution of this system or nothing else. That is the row equivalent matrix or nothing else. So whatever the solution you will get, that is the original solution. So you just see that system, after transforming original system into the upper triangular form, simply will solve this system. In this system, from the last equation, you can able to solve x3 easily. What is the x3? 3 by 6. That is half. After, you just tell me, after getting x3 from the second last equation or second equation here, can you able to solve x2 easily?
Yes, sir.
After doing simply calculation, you just bring all that term right hand side, you will get x2. Okay. What is
Yes,
x2? What is x2 then?
minus 3/4.
So x3 is actually half. Half if you will use here, you bring that is right hand side. So it will be positive. So minus 5 and this half 2 cancel means it will be minus 1. Right hand side it will be positive. So it will be minus 4 right hand side, and 4x2 equals to minus 4 means x2 is minus 1. Isn't it? And after getting x3 and x2, if you will use in first equation, that two value, known value, you can able to calculate x1 easily.
Yes, sir.
So from back side, you are substituting the values, and you are getting step by step from last value, second last value, in that way up to first value. Is it clear? What is x1?
Yes, sir. So x1 value, okay, 1 minute.
x1, you just bring all that term right hand side and you will get x1. Can you able to solve this x1?
4, sir.
That is 4, no problem. So these are the solution. x1 4, actually in this method, actually from last value will be come out first. So x3 half, x2 minus 1, x1 4. These values you just put in the main equation, every equation will satisfy. This is the solution, and that is the exact solution also. And for clearance of that technique quickly, you just try to solve theoretically. Can you able to solve this problem or not? What is I given you in the actually in the program? Actually in the program I given you actually 4x1 plus x2 minus 2x3 equals to 0. 2x1 plus 4x2 plus 2x3 equals to 15. Have you seen the question? 2x1
Yes, sir.
plus. Same question I given there, okay. And theoretically you just try to solve it, and then you will try to solve with the help of computer. What I told you on that way, you just tell me what will be the first step. First step, structure of the matrix, what it will be, or structure of the system. With the help of first equation, first position 0 in remaining equations. First equation unchanged. x2, 2x3 equals to 0. How it will be 0? That operation you just tell me. Which binary operation I am doing in R1 such that R2 will be updated, this position will become 0.
R2
So,
minus
R2 does
half
equals
of
to
R1.
R2 minus half R1. So I will do half into R1. That operation I will perform for remaining element, and this position will become 0. That is you have to pick up by watching the elements when you will do solve theoretically. And with the help of this relationship, you have to build the formula. And this position 0 becoming 0, and that operation is simply I am doing multiplying R1 half and subtracting. So 4, what will be this position? This is 0. Okay, no problem. What will be this position? 4 minus half. 4 minus half means 3.5 means 7 by 2 x2, isn't it? And 2 minus minus plus 1 means 3x3. And actually I am multiplying in R1, but this position 0. So it will be simply 15 minus 0 into 0 into half. 0 into half 0. So 15 is unchanged, isn't it? What will be this position then? Tell me. This position. 1 minus half. R3 dash equals to R3 minus half R1. If I will do, then this position will be 0. Then that operation I will perform here also. So 1 minus half. 1 minus half, isn't it? X2 and 2 minus minus plus 2 by 2 means 1. Means 3x3 again equals to minus 5. Minus 5 minus 0 into half means 0. So these two positions become 0 with the help of this operation, and that operation I will perform here, and that values are updated here. You got this? Step 2. In step 2, up to second equation unchanged. X1 plus X2 minus 2X3 equals to 0. This is 7 by 2 X2 plus 3X3 equals to 15, and half X2. Sorry, actually that is I have to update, and I will make this position 0. How it will become 0? That operation you just tell me. With the help of R3 in old R3, what I will do along with R2. R2 में क्या करेंगे? 1 by 7 multiply करेंगे.
Yes, sir.
1 by 7. If I will multiply here 1 by 7, then it will be half. Then half minus half cancel, so this position will be 0. So I will multiply in R2 1 by 7 and subtract. Then this position will be 0, and that operation you just remember and you just do perform in remaining elements. So what will be then updated this position? This is 0. Okay. What will be this position? 3 minus 3 by 7. 3 minus 3 by 7 means 21 minus 3 means 18 by 7, isn't it? And what will be the right hand side? Minus 5 minus 15 by 7. Minus 5 minus 15 by 7 means minus 50 by 7. You just see your original matrix in rectangular form. That is rectangular form. But this is in upper triangular form. So your coefficient matrix will transform in this way. In which way I am telling you? Actually, this way of process of understanding will help you to build the algorithm, and that is why I am telling you. Main logic is you are transforming your coefficient matrix into the upper triangular matrix with the help of some elementary row operation. Now, here is also from last equation, you just tell me the value. From up, you will get from last equation x3. Use that x3 here in second last equation, you will get x2. Use x3 and x2 in first equation, you will get x1 from back substitution. What is the x3? Minus 50 by 18.
18.
Minus 50 by 18 means minus 2.777, like that. And if you use x3 value in second last equation, you will get x2, x3 value in second last equation, you will get x2 as, you just, okay, bring this right hand side and calculate numerical value, divide by 7 by 2. It will give you 6.6666, like that. Okay. And if you use these two value, x3 and x2 numerical value in first equation, bring that two term right hand side, divide by 4, you will get x1. X1 will be minus 3.0555, like that. Okay. This is the process of back substitution. Means method is clear.
Yes, sir.
Now, actually, logic is how you will build this. That idea I am telling you. Try to try to take input of the given system. Suppose this is the system. For this system, take all the input. For the input purpose, you just take the coefficient matrix. Take the coefficient matrix, input. Take input all right hand side. Okay. And for the step one loop, you just continue one loop for the steps. Suppose step is K, and for suppose step reducing steps. So for steps this, and for your suppose this J pointer is moving here, I pointer is row. So suppose for I and for J, with the help of these three loops, for one for step, another for within the row calculation, and this is for every row calculation. You may within this three loop, you may put this formula structure in such a way your original matrix, whatever the Aij you have taken, that will be replaced by upper triangular Aij. And for that purpose, your new Aij will be built from old Aij minus Aik into Akj by Akk. That will be the formula. From this elementary row operations, you just build this. Similarly, right hand side, Bi will be built from old Bi minus Aik Bk by Akk. So within this three loop, if you can able to rearrange these two operations, it will replace, input will be replaced by upper triangular matrix Aij. And then for the back substitution process, within a loop, step by step, you just print all the last value to first value variables or output. That is your work. You just try to do that work today. Otherwise, I will help you later. Okay. And that loop idea also, I am telling you, suppose suppose n, this is applicable for n number of equations, so you just take n input. N is the number of equation, and so you are in the loop, you are considering 0 to n minus 1, means n values. So k will give you the steps. So you just tell me for 3 by 3 equations or 3 variable 3 unknown, how many steps you need?
2
steps. Suppose n equation is there, n unknown is there, how many steps you will need there?
n minus 1.
So for that purpose, 0 to k less than n minus 1. So 0 to n minus 2 means n minus 1 steps, k plus plus. And in first step, it will calculate k plus 1, means not 0 row, means first row. K plus 1, I less than n, all the variables I plus plus. And j is also for the next step up to that much unchanged, means first position 0 in first step. So I am starting from k plus 1 as value calculation. If I will do this operation, first position 0, so I will start from next variable, so k plus 1 to j less than n, j plus plus 1. Within these three loops, I will put these two commands, and these things you have to define within the main program at the top in array format. Okay, 2-dimensional array format, right hand side 1-dimensional array format. Take nicely all the inputs within these three loops, try to build this formula, then you just try to calculate step by step from last value to remaining all values from the back way within a loop and print them values, it will give you the results. Try to implement that. Okay, can you able to do this or not? Then you just tell me.
So can you show the last slide?
This one.
Yes, sir.
This one up to actually main work is take n is the suppose printf n is the number of equations. Then you just take row wise all the elements with the help of 2 for loop, because this is 2 dimensional. Then you just within a loop, 1 for loop, you just take all input of right hand side bi. Then within this 3 loop, you just complete these 2 comments. Then it will transfer old aij into the new aij. Old aij is this replaced by new aij, and then after completion of these loops, these aij are the values of the upper triangular matrix. What is the last step of the Gauss elimination method? Okay, and from that matrix, last variable will be calculated manually, and remaining all values you just try to calculate by replacing process. For that purpose, a formula of back substitution that is also within a loop. And that is the idea of algorithm of this method. Just try to develop this. Okay, I am sharing that screen is shared here. You just see and watch.
Yes, sir. Yes, sir.
Okay.
But the substitution part, how it will be carried out?
Substitution part. After completion of that things, actually, where I will write that? Actually, let me take. Is it that 3 for loops is visible?
Yes, sir.
Okay, within this, you just close these 3 for loops here. You will close. After closing that, actually, this is now your upper triangular form. In this is for 3. Okay. So, what is the last variable for this equation?
Sir, x3.
X3, and for this system,
x2.
x0 to xn minus 1. X0 to xn minus 1 is the variables.
Sir, we have to store this equation in the matrix now.
Actually, you are that variables is you just simply define in float. Suppose x. Suppose x. How many variables are there? Suppose xn. Okay. So that is the maximum dimension. That is you just put suppose 200. No problem. So logically, whatever the n input you will take, on that basis, last value is your first value is x0, then x1, in that way xn minus 1, and whatever you will consider on that basis, that is the last variable. So last variable xn minus 1, actually for that example, x1 equals to x0, actually x2 equals to x1, x3 equals to x2.
So it means we have to take 3 different arrays for this.
Yeah, 3 different arrays. For the coefficient elements, aij, right hand side element bi, and for the variables xi. Sorry, x within the bracket whatever, but that will be stored or used within the at the last. Suppose you are whatever the n input you have taken, that xn minus 1 is the last variable. How it will be calculated? Right hand side you got after the completion of this loop, b n minus
B3
bn minus 1, bn minus 1 by your in this coefficient, that is the actually an minus 1 two-dimensional an minus 1, that is the last variable. You just manually print this. Manually you just print this last variable. Okay, that is the solution of last variable. You have to use in the second last equation and then second last equation in that way, step by step from the back side. Using this, you will basically, this is the initial value to calculate remaining values. Okay, so for that purpose you have to use a loop. Suppose for loop you are using here, and suppose actually back substitution loop, no. So for k equals to 0, and how many steps I have to reduce? K less than n minus 1. Reducing command I am writing later. Okay, k plus plus. For the time being, you just try to understand. That much steps I do have. How many steps I do have? 0 to n minus 2. 0 to n minus 2. So that steps I have written here. Okay. In that step, all values I will calculate. But in reducing way, for that purpose, what I am doing, I equals to n minus k plus 2 I am doing. N minus k, k0 means n minus 2. N minus k, if I do n minus 1 value already calculated, then if I will use k0, then n minus 2. N minus 2 means next value will be calculated. And another loop I am putting here, j I plus 1. J less than n, j plus plus. Then what I am doing, actually I am bringing all the terms. Suppose from the second last equation you just see, along with right hand side I am bringing this term right hand side. Okay, and that is I just rename by new bi. That is, after bringing all the term right hand side, is build bi minus aij star this x values xj. aij xj. So new bi, after bringing all that term right hand side, new bi already built. Then what is the values of this x2 coefficient? That coefficient I will divide. Then that will be the new variable. So xi will be bi by aii. Actually, this is so you just see here, this is the last value. That is the total step I have written, but to reducing purpose I have used a comment here I, and for j equals to I plus 1 from next variable, not this variable, from this variable, all that term I am bringing right hand side, and that is renamed by new bi. That new bi, actually xi, that will be calculated right hand side. What is the new bi already built after bringing all that term right hand side? That is I am dividing its coefficient aii, and that within the loop you just print all xi. So last value this, and these are all remaining values. After completion of this program, it will give you, if this equation is the, within this loop you just print xi. So last value already you have printed. Suppose you are considering n x n minus 1 here. You will print here. Then if you will take input n equals to 3, then it will give you x0 to first. Then within these two loops, two value, sorry, x2 equals to value first. This value first, then x1, then x0. x1 and x0 will be coming from the loop, and x2 will be printed as the last value. You got my point?
Yes, sir.
Try to implement this. Actually, these slides, am I able to इसको फाइल सेक्शन में अपलोड कर दें बाबू?
Okay, sir. कर दीजिए सर.
फाइल सेक्शन में अपलोड कर देते हैं. प्रीवियस सेम नेम पे जो फाइल है उसको डिलीट कर देते हैं, इसको अपलोड कर दे रहे हैं. ठीक है ना?
Okay, sir.
Then you will see the algorithm part also along with the examples.
Sir, turning time थोड़ा increase कर दीजिएगा please.
Okay, no problem. I will increase.
Sir, 8 या 9 बजे तक कर दीजिए ना please.
और ये तो 9 बजे तो उतना लेट क्यों?
सर बैंक से आया अभी जस्ट डीडी वीडी बनवा के सर बहुत थक गए.
वाह, वेरी गुड. How many students you are present? Let me check. Okay, you will do it. I will do it. I will increase your time. Okay. Overall assignment, that file are you seeing here?
Yes, sir, it is visible there.
Overall assignments, actually that syllabus I have written there nicely. Your syllabus I have written there nicely. Which are the things you have to study nicely? And these are the subjects. This is your actually iteration method to solve the single past lecture. This is your lecture, no? Iteration method. This is your lecture. That lecture I am deleting. Again, I am uploading that lecture. Actually. Okay, in that lecture at the last portion, today's class is there. Okay. For your reference, you will see here, and that question that is also we have solved there, which is you have to do in not MATLAB. Actually, you have to do in computer with the help of C program. That is also I have. Question you got here?
Yes. Yes, sir. Assignment is visible, sir.
So what I'll do? Update.
Times. Yes, sir.
What is the time? Edit assignments. Edit assignment. Then due time is 7:30 or 8.
8 would be better, sir.
Due time and close time, both time I am keeping same. Okay, within that time you have to complete. Okay,
Sure, sir. Thank you so much,
you
sir.
have to upload. Okay.
Okay, sir. Thank you, sir.
So you just take your time and try
Okay,
to
sir.
complete it.
We will submit within the time.
Okay. And if you do have any trouble in understanding still, maybe you should upload your error file also. But if you do have any query, you should ask me in next class. Okay.
Okay, sir. Or we will send you a message on WhatsApp group, sir.
Yeah. In WhatsApp group also you will send queries. Okay.
Okay,
But
sir. Thank you, sir.
I am actually asking you, just if you will get error also, that time also whatever the work you have done, that work you just try to upload. Actually,
Okay,
it
okay.
is not
Sure.
matter. File is important. You have uploaded. That is important. It will be considered as your potential attendance for this class. Means you are
Okay, sir.
doing. You have done that. Actually, for the sessional assessment, I will consider this potential attendance, as well as you will get some marks also. Okay.
Okay, sir.
Okay,
Thank you,
sir.
sir.
Thank you, sir.
So we are ending the meeting for time being. Okay.
Okay, sir.
Thank you,
Thank you,
sir.
sir.